be doing integration by parts for this question. So the first thing we need to do is I have the formula up here, and we just need to choose u and v. So I'll take the top of the equation as u, natural log of x, and I'll take the bottom as v. Now we just need to find the derivative of u and the integration of v. So the derivative of u is the natural log of x, which is 1 over x. And then the integration of v, we just take this, and 1 over x squared is equal to x minus 2. Now using the power rule, we should get x minus 2 plus 1, or to the power of minus 2 plus 1 over minus 2 plus 1, which is equal to x minus 1, to the power of minus 1 over negative 1, which is equal to negative 1 over x. So I'll pop that over here. Negative 1 over x. Cool. Now we have all this the components of this formula up here, so we just substitute them in. So natural log of x minus 1 over x, brackets, minus derivative of u, 1 over x, and then again the integration of v, which is negative 1 over x. Cool. And then just simplify. So negative natural log of x over x minus, here when we expand the brackets, we're going to get negative 1 over x squared. And we know from when we integrated v down here that when we had this as a positive, we got negative 1 over x. So if we make this a negative, we can move this over. So the answer for this one should be 1 over x. So we should, once simplifying again and solving, x minus 1 over x. Cool. And simplifying that further, we get negative natural log of x minus 1 over x. So now we have a really neat and tidy equation. And going back to the limits, up here, we just have to sub them both in and minus the 1 on the e. So first we'll sub in e, so natural log of e minus 1 over e. The natural log of e is 1, so we've got minus 1 over e. So the answer is negative 2 over e. Now we just need to sub in 1. So that means we've got natural log of 1, which is 0. So we've got negative 0, which is 0 over 1, which means this simplifies to negative 1. So we should get negative 2e minus 1. Once we do that, we get negative 2 over e plus 1, and then we can check and see if we're integrating. There's the answer.
Hello, my name is Lachlan and I'll be presenting question 3 part E for this week's tutorial. So for this question, it involves finding the partial fraction decomposition for this expression here. So the first thing we can see is it is a proper fraction, so there is no need for long division, just because we know the highest power to x is x cubed on top, while on the bottom, if we expanded it, it'd be x to the power of 6. So we can just go ahead and go straight into the partial fraction decomposition. So we can see we have two distinct linear factors here, x plus 2 and x minus 1. And then we also have a repeated irreducible quadratic of the x squared plus 1 squared. So how we write this out is a over x plus 2 and plus b over x minus 1 for the distinct linear factors. And then we use the form of the line for the quadratic. So cx plus d over x squared plus 1 plus ex plus f over x squared plus 1 squared for the repeated factor. Now, the next step is getting both sides over a common denominator. So we just bring this back down here, and then we times out whichever factors the constant doesn't have as the denominator. So a x minus 1 times x squared plus 1 squared plus b x plus 2 x squared plus 1 squared plus cx plus d, and then we have to times that by x plus 2, x minus 1, and x squared plus 1. And then finally, plus ex plus f times x minus 1, x plus 2. And that'll be over x plus 2, x minus 1, x squared plus 1 squared, our common denominator. Now, because both sides have that same denominator, we can just get rid of it and express it as follows here. Now, the question doesn't ask for us to find the constants, so we can leave our answer here. Thank you.
The next question we're going to be evaluating is 4b, which asks us to evaluate the following integrals. So we're going to start by writing out the fraction that was given to us. Upon evaluating this fraction, we see that in order to simplify, we can complete the square for the bottom half of the fraction. When doing this, we get x plus 1 squared plus 9 for the denominator of the fraction. Then we can use substitution, being u equals x1, in order to simplify the top and the bottom of the fraction. The next thing that's important to do is split the integral into two fractions. We do this by keeping the same denominator for both and splitting the numerator between the plus sign to make two different fractions. We then include the integral sign and du at the end of each in order to signify two different integrals. Turn to the table of integrals to have a look what could we use to further simplify and evaluate this integral. We see that number 2 on the table of integrals can be used, so then we implement this. When doing so, we take common fractions out the front, which then further simplifies the remainder of the integral. And the last step, of course, is to substitute u back into the original equation. So we substitute wherever there's a u, we put in x plus 1. This brings the fraction back to the original equation and allows it to be complete. Don't forget to add plus c on the end in order to show a constant, as it is undefined.